The other part of it is that you're going to be asked to graph um, these things. Now, if they give them to you in standard form, that's easy enough because you have all the parts you need to come up with the information you need to, or the points you need to draw an accurate graph. And it should take, I mean, once you get the hang of doing it, it doesn't take you that long to do it. If it's written in general form, though, that gets to be tricky because, first of all, it kind of hides which one it is. Because, I mean, these standard forms, I mean, like, aside from the ellipse and hyperbola looking a lot alike, um, except with the difference of a plus or a minus symbol. And of course, if you start off with the y, you see a minus symbol, it's hyperbola versus an ellipse. But parabolas versus those other two, and a circle equation, which is just a variation of your ellipse equation, they kind of look different than those. I mean, so those. I mean, if you see a certain structure, that will alone tell you, hey, it's a circle. Sometimes they can mislead you though, so be careful. If it's written in this kind of format, that's kind of hidden. So it's going to be our goal to eventually put it into one of those standard forms. And because of that, I'm going to want to have an idea of what standard form I'm going to try to get this thing to look like when I'm done. And to do that, I have to know what kind of conic section it is. If you go with these guidelines, you should be able to look at any conic section equation written in general form and within 3 seconds tell me what kind of conic section it is. Because the first thing, I'm always going to look at the a and the b values. If a equals 0 or b equals 0, and what that means is I'm either going to be missing my x squared or I'm going to be missing my y squared. I'm not going to be missing both, but if I'm missing x squared or y squared, it's going to be a parabola. Because when I ultimately solve, I'm going to solve for I'm going to isolate the variable that isn't being squared, and that would give me something that looks like a parabola. Whether I'm isolating the x or isolating the y, I'm going to have that equaling to some square value of the other one. So if either one of those is 0 and that x squared or y squared is missing, it's a parabola. If a equals b, then it's a circle. Which means I could either have an ellipse equation for it where, my a squared and b squared are going to have the exact same value, or I could have that, more, specific formula geared towards circles where I had the x minus a squared plus y minus k squared equals r squared. The conic section is going to be an ellipse, and I mean a non-circular ellipse primarily, if a and b have the same sign. So if they're not equal to each other, it means it's not going to be a circle, but it can still be an ellipse. And if it's an ellipse, a and b are going to have the same sign. So if I see that whatever number I have in front of x squared is positive and the number in front of y squared is also positive, it's an ellipse. If I see that they're both negative, it's an ellipse. So that's the one thing we have to keep in mind here. The last one, for it to be a hyperbola, if I look at a and b and they have opposite signs, that's an indication that's a hyperbola. So if the number in front of my x squared is positive, the number in front of my y squared is negative, of course that precludes them from being equal to each other, so it's not going to be a circle. They have opposite signs, it's a hyperbola. So again, once you train yourself and to look for the a and b values, which again, that's numbers in front of the x squared and the y squared. If it's in this format, those would be the first two numbers, but be aware that a is in front of the x squared, b is in front of the y squared all the time. In this form, it's not the same as the a and b we mentioned in the standard forms. Okay, a and b are different things here. All right.